Okay, first we're going to talk about how to solve for a segment in a circle whenever you use the formula for secants or tangents and you determine that there's an x squared term. Whenever you have an x squared term, you have to treat it differently than if you just have an x term that you can use multiplication or division, addition, subtraction, and you can just isolate x. But in this case, when you have an x squared term and an x term, you have to use something called the quadratic formula. Well, there's other ways to do it, but in this case, we're going to use that one. So, basically what happens is on question number 6 in the skills practice, whenever you use the formula for the different segments of the circle, you find out that you have an x squared and an x term. In order to solve for x, you can't use the same kind of methods that we've been using in the past because there's not just one answer for x, there's actually two because there's a square term. So the first thing you need to do in order to use the quadratic formula is get it into the correct format. And the correct format is where you have the x squared term, the x squared, and whatever constant you have left over are all on one side of the equal sign so that everything is equal to 0. So if you were to have something on the other side, you just simply move it by adding or subtracting, doing whatever the opposite is to get it to the other side. Once you have it in this format, whatever coefficient is in front of x squared is called a. Whatever coefficient is in front of the x is called the b term. And then whatever constant you have is called the c term. Make sure you keep your signs with your a's and your b's and your c's. Otherwise, the quadratic formula won't work. And again, the quadratic formula is just simply a method used to solve for x because you can't solve for it in traditional methods when there's a square and an x term. So here's the quadratic formula. You'll want to put it on your note card. And at this point, what you do is you take wherever b is and you put in the number for b. Whatever the number a is, you put it in wherever there was an a. And whatever c was, you put it in for c. Keep in mind that everything is over 2a. So the b part is over 2a and the radical is over 2a. So don't drop it as you have to keep rewriting the different steps of your solution. So here I've plugged everything in. And remember, like I said, the A goes where the A, B goes where the B, and C goes where the C. And you continue to just evaluate each part as you go. And then eventually you go down and look at your answer. If you'll notice, the plus or the minus means that there's two answer solutions for x. It's whatever negative b plus whatever the simplified radical comes out to be, and you divide by 9, or negative b minus whatever the radical simplifies to be divided by the 2a. So whichever, you have to do both of those operations because x has two answers. So here on the left I added the numerators and divided by 2, and here I subtracted the numerators and divided by 2. Now, since we're talking about segments of circles, obviously a segment of a circle can't be negative, so we choose the answer choice where it's positive. Let's look at another example. That was question number 6, and we're going to do the next question. Question number 7. Again, we're going to use the same formula that we learned in class. And in this case, it's a little bit different because you only have an x squared term. You don't have an x term as well, so you don't have to use quadratic formula with the x squared only term. So if you simply take the square root of both sides, then you can solve for x that way. Now when you take the square root of both sides, you can get positive 12 or negative 12 because negative 12 times negative 12 will give you positive 144. But we'll only use the positive choice since, again, we're talking about length. All right, so here's a couple of examples of problems 8 and 9 for the skills practice. Again, number 8 turns out to be where there's only one x, so you can solve for it using traditional methods. Number 9 does turn out to have an x squared term and an x term, and because of that, we're going to use the quadratic formula. Remember, we want to rearrange it so that we have an x squared term, an x term, the constant, all on the left-hand side, so that we're equal to 0. A is whatever's in front of x squared, B is whatever's in front of x, and C is whatever's left over. You plug it into the quadratic formula and solve just like here. When you get down to this bottom step, like I said, you're going to choose the addition of the numerators option and solve for x, and choose the subtraction of the numerator option. And in this case, I can just tell already that the answer is going to be negative, so I can get rid of that. All right, let's talk about how to write equations of circles. It's pretty straightforward, actually. They give you the equation of the circle. They tell you that the equation of the circle is simply x minus h squared plus y minus k squared is equal to r squared. Now, what you need to know is that h and k are the x and y coordinates of the center of the circle. So h comma k is the center, meaning h is the x term, k is the y term for wherever the center is, and then r is the radius. Now keep in mind that whenever you're writing equations of circles, that it's equal to r squared. So the radius, the square root of this number is actually going to be your radius. Now remember, what is a radius? A radius is simply the distance from the center to any point on the circle. Okay, so here one of the answers, or one of the questions, number 1 says that the center is at the origin and the radius is 6. So h is 0, k is 0, and the radius is 6. And so you simply put in 0 for h, 0 for k, and 6 for r, and you evaluate it. And since there's zeros there, there's nothing more to do for the h and the y part. Again, the center is at 0, so there's an h and k. They're both 0. The radius is 2. You square it, and it's pretty straightforward for the circle. Now here you actually have a center, so h is 4, and h goes with x, and y is, k is 3. So remember, it's y minus k, so that's why these negatives are there. That's part of the formula. And then the radius is 9. You square it, and you get 81. All right, here's another one. The center is at 7, 1, so h is 7, k is 1. Aha, they gave you a diameter, so half of the diameter is 12. So you put in 12 for r, and we can go ahead and square it and just put it in the formula. All right, let's look at number 5 on that same page. It gives us a center of -4, -1. And it says that it passes through -2, 3. Well, that's not really a radius. But one thing you do know about the radius is that the distance from the center of the circle to any point on the circle is the radius. So since you need to find the radius in order to write the formula for the circle, or the equation of the circle, then you're going to need to use the distance formula. Now the distance formula is the difference in x's squared plus the difference in y's squared, and it's a square root. So essentially it's the same as the Pythagorean theorem. So here's our x terms, -2 minus a -4 squared, plus our y terms, 3 minus a -1 squared. And then we put it into this formula, and we continue to evaluate it as we go down. So we eventually get that the radius is the square root of 20. Well, we don't really need to evaluate that, because for the formula of the circle, we're going to be squaring radius anyway, so we just went ahead and squared it. Now remember, the square root of something that's squared is simply the same thing. It's inverse. Square root and squares are inverses of each other. So we just get 20 back out. So we know the center from what it said above. It's x minus h, and h was negative, so minus a negative gives you a positive. Y minus k, again k was negative, so you get a positive. And since we squared the radius and got 20, that is our solution. All right, let's look at some more. Number 6, we also have a similar problem where we have a center of the equation, or center of the circle, is at 5, -2. It passes through 4, 0. Again, we're looking at the distance to find the radius, so try it before you just copy down what's on the video. Okay, so the distance formula, we're going to use the difference of x's squared plus the difference of y squared, and continue to evaluate those, and you get the distance or the radius is square root of 5. So when you square it, you get 5. Put it back in our formula, and there is our answer. Okay, now let's do a little bit more with circles. Number 7 starts with a different kind of problem. They basically give you a circle and then ask you to find the center, or actually the first part just asks you to write the equation of the circle. So the first thing you need to do is find the center and the radius. So here we found the center at 1, 2, 3, 1, 2. So the center is at 3, 2. That's our x and y coordinate. And then our radius. Let's look at our radius. So the radius, remember, is the distance from the center to any point on the circle. Well, it's a lot easier to count how many units it is from north, south, east, west, basically, or up, down, left, or right, just because you can count whole units. So in this case, h was 3, and remember it's x minus h, that's why there's a negative there, and y minus k, so since they're positive, you're just subtracting a positive. And then the radius squared. The radius was 2, so 2 squared is 4. Center is at 0, negative 2. The radius is 3. I just counted 3 units over in any direction from my center, and then I plugged it into the formula, or the equation of the circle. All right, let's look at another one. This section tells you state the coordinates of the center and the measure of the radius, then graph it. Now, graphing circles is not an easy task, drawing any kind of circle. So pardon my circles that I've drawn. Okay, so in this case, h is next to x, so there's nothing there, so that's a 0. And y is next to k. There's nothing there, so that's also a 0. So the h and the k are both 0, which means the center is at 0. My r squared is 16, so that means my r is the square root of 16, so it's 4. Looking at number 10, similarly, first we find our center, and so our h is x minus h, so h is positive, and y minus k, so k is positive, so my center is at 1, 4. Oops, I see my circle needs to be shifted over. So the center is actually here, not there, and then you would draw a circle that way around this center. I drew it at 0, 4, so my apologies for that. All right, and then the r squared is at 9, so that means the radius is 3. So make sure you do that correctly on your paper. All right, number 11, it says write an equation of a circle that contains each set of points, then graph it. Okay, so what I did was I first graphed these 3 points. A was at negative 2, 3, so here's A. B was at 1, 0, and C was at 4, 3. And when I looked at these, I saw, you know what, these 3 look like that they're all the same distance from this point right here, 1, 1, 3. So since they're all the same distance, the center must be 1, 3. So that's H, and that's K. And then since they're all 3 units apart, then that means the radius is at 3, and 3 squared is 9. Again, I did the same thing on number 12. So 3, 0 is F, 5, negative 2 is G, and then 1, negative 2 is H. So when I looked at these 3 points, I said, hey, you know what? They look the same distance from this point right here, which is 3, negative 2. That's my center. So 3 is H, x minus H, and negative 2, when you minus a negative, you get a positive. My radius is 2 units. Everything is 2 units apart, so my r squared is 4. Okay, work on your practice. Check your answers on It's Learning, and don't forget to do your review tomorrow. Thank you.